Good morning children. Once again welcome to digital learning on TSAT. Today we are going to have the second session on the topic reflection of light at curved surfaces. So children, I hope you remember what we have learned in our previous topics. So first let us have a review of what we have learnt. Children, in our previous session we learnt about two types of spherical mirrors, the concave and the convex mirror. We have seen that the reflecting surface in a concave mirror is bent inwards and it is called a converging mirror. Then the reflecting surface in a convex mirror is bent outwards and it is called as a diverging mirror. Then children, we went on to discuss some important terminology related to the curved surfaces, that is the pole of the spherical mirror. The geometric midpoint of the spherical mirror is called as the pole of the mirror. The line passing perpendicularly through the pole of the mirror is called as the principal axis. The point on the principal axis where all the normals of the curved mirror intersect is called the center of curvature. Yes children, this we have also defined as the center of the big spherical mirror from which the mirror is taken. Then we went on to discuss the definition for radius of curvature. The distance between the pole of the mirror and the center of curvature is called the radius of curvature. And then children, we have also defined the focus of a concave mirror. The point of the principal axis of a concave mirror where the reflected rays converge and meet is called the focus of a concave mirror. Okay children, the concave mirror is a converging mirror, so all the light rays come together and meet at the focus. That is the focus of a concave mirror. The point on the principal axis of a convex mirror where the reflected rays appear to meet behind the mirror, they appear to meet behind the mirror is called the focus of the convex mirror. Then we also discussed the distance between the pole of the mirror and the focus is called as the focal length. Okay children, all these definitions, all these terms are very important in understanding this chapter. Okay children, now let us come to the activity part of the chapter. Children, this is a very important activity that we are going to discuss today, both for the understanding of the concepts as well as in your examination point of view. So we are going to perform a lab activity or see a lab activity to observe the images formed by a concave mirror for different object positions. Okay children, what do we understand by this? In this experiment, we are going to take an object and place it at different positions from the concave mirror and observe the images so formed by the concave mirror. So first of all children, let us see what we need for this activity and how is the experiment arranged. Okay children, in this experiment we need a concave mirror. Okay children, we need a concave mirror. We need a V-shaped stand to place the concave mirror. We need a candle which acts as the object. We need a candle which acts as the object. We need a white paper which acts as the screen. Okay children, once again let us look at the apparatus. We need a concave mirror. We need a V-shaped stand to keep the mirror, to hold the mirror. We need a candle which acts as the object. We need a white paper. We need a white paper which acts as a screen, and we need a scale to measure the distances. We need a scale to measure the distances. Okay children, so this is the apparatus that we are going to use in this activity, and this is how the apparatus is going to be arranged. Okay, the mirror is fixed at one place. The object is kept at a distance, that is it will start from 10 centimeters and move farther away from the mirror. the screen is adjusted to get a clear image and both the distances are measured. The distance between the mirror and the object is called as the object distance. The distance between the mirror and the object are called as the object distance. It is given by small u, and the distance between the mirror and the screen, where the image is formed, is called the image distance and denoted by small v. Okay children, now let us see the demonstration of this lab activity. So as discussed earlier, we have seen that the mirror has to be fixed at one position. Okay children, the mirror has to be fixed at one position. Mark this place as the pole of the mirror, and the object is initially kept at a distance of 10 centimeters. Object is kept at a distance of 10 centimeters. You can see that the image is formed in the concave mirror. How does the image appear, children? Yes, the image is appearing to be very big. It is appearing to be enlarged in size, and it is an erected image, that is a straight image. Okay children, at 20 centimeters, adjust the position of the screen. We are moving the screen far away and nearer to the mirror, but we are unable to capture a clear image of the candle. Okay children, this means that we of the at 20 centimeters distance. Right children? So here we note that the image is forming at infinity. We note that the image is forming at infinity. Okay children? Now let us move on to 30 centimeters. Let us place the object at 30 centimeters. What happens when we place the object at 30 centimeters? Make a note of the image. When you place the screen at different positions, you will get image in many positions, but at a certain distance you are getting a clear image. Observe it children. You are getting a clear, sharp, inverted image. You are getting a clear, sharp, enlarged and inverted image of the object at a distance of 57.5 centimeters. Okay children, so this is the image distance for object distance of 30 centimeters. Next, place the object at 40 centimeters. We can see that the image is formed at 40 centimeters again. The image is formed at 40 centimeters again, and you can see that the image is of the same size and it is again inverted. Remember children, whatever images we are seeing on the screen are all real images. Okay children. Then let us move the object to 50 centimeters. When we move the object to 50 centimeters, the screen appears in between, the image appears in between the mirror and the object. Now the size of the image gets diminished, but it is still inverted and you can still see it on the screen. That is, it is a real image. Now we are getting the image distance as 32.5 centimeters. We will make a note of it and we will try to infer some data from it. We have taken the object at different positions from 10 to 60 centimeters, and we have seen the various image positions. Okay children, we have seen the various image positions. We have also made a note of how the image appeared, whether enlarged or diminished or inverted or erect. Okay children, so here u is the object distance, v is the image distance. This column tells us about the size of the image and this tells us whether it is inverted or erected. Okay children, so for 10 centimeters we could not find the image distance as the image was formed in the mirror itself. It was enlarged and erected. At 20 centimeters the image we said forms at infinity. At 30 centimeters the image formed at 57.5 centimeter. It was enlarged and inverted. At 40 centimeters we saw the image formed at 40 centimeters only and it is the same size and inverted. Similarly, at 50 centimeters the image formed at 32.5 centimeters and it was diminished and inverted. At 60 centimeters the image formed at 23 centimeters and it is diminished and inverted. So children, when we observe these values, we can say that as the object is moving away from the mirror, the image is getting closer and closer to the mirror. At the same time, its size is getting diminished. Gradually the size is getting diminished. Okay children, for this lab activity, we have taken a mirror of focal length 20 centimeters. Okay children, we have taken a mirror of focal length 20 centimeters. So based on the value of the focal length of the mirror, what do you get in mind? As soon as you think about focal length 20 centimeters, the radius of curvature becomes 40 centimeters. So based upon the value of F and R, we get all these inference from our values. That is, when the object is kept between P and F, the image position is behind the mirror. It is enlarged, erected and virtual. When the object is on F, the image position is at infinity. When the object is between F and C, that is 30 centimeters, object is at 30 centimeters, the image position is beyond C. That is, the image position value will be more than C value. It is enlarged, inverted and a real image. When the object position is on C, image position is also on C. It is of the same size, inverted and real. When the object is beyond C, then the image position is between F and C. It is diminished and inverted and real. Finally, if the object is at infinity, okay children, if the object is at infinity, this you can understand from the focus definition, the image position is on F. The image is highly diminished, it is inverted and again it is a real image. So children, I hope you have understood the demonstration of the activity and whatever data we have inferred from it, whatever information we have interpreted from it. Okay children, now we are going to see the diagrammatical representation of the same interpretation. Learn some rules for drawing the ray diagrams. We will start with the concave mirror. The first rule says, if the incident ray to the concave mirror is parallel to the principal axis, if the incident ray to the concave mirror is parallel to the principal axis, then the reflected ray passes through the focus of the mirror. The reflected ray passes through the focus of the mirror. Okay children, you can see here a light ray incident parallel to the principal axis is falling on the mirror, and after reflection it is passing through the focus. So this is the first rule. Okay children. Rule number 2. If the incident ray is passing through the focus of the mirror, you can see the incident ray is passing through the focus of the mirror, then after reflection it passes parallel to the principal axis. The incident ray is passing through the focus of the mirror, it hits the mirror and after reflection it passes parallel to the principal axis. Rule number 3 says, if the incident ray passes through the center of curvature, if the incident ray passes through the center of curvature, then the reflected ray also passes through the center of curvature. You can see a single line but 2 arrow marks. That means this is the incident ray and this is the reflected ray. Both travel on the same line. Okay children, the reflected ray retraces the path of the incident ray. This is rule number 3. Rule number 4 says, an incident ray when it hits the pole of the mirror, an incident ray when it hits the pole of the mirror with an angle theta, then it gets reflected with the same angle theta on the other side of the mirror, on the other side of the principal axis. Okay children, the incident ray coming from the object hits the mirror at the pole and it reflects such that it is making the same angle theta and reflecting from the other side. Okay children, so these are the 4 rules that have to be followed while drawing the ray diagrams. Once again children, ray diagrams are very important concept to us. So what do we need to draw a ray diagram? We need at least 2 rays. We need at least 2 rays to draw a ray diagram successfully. Okay children, we make use of at least 2 rules. Okay children, to draw a ray diagram properly, we make use of at least 2 rules. Now let us start the ray diagrams for concave mirrors. Okay, children? The first case, the object is placed between the pole of the mirror and the focus. Okay, children, you can see this is a concave mirror. The object is placed between P and F. The object is placed between P and F. Okay, children. Now let us see how the image is formed. The pole, focus, center of curvature, object, a ray parallel to the principal axis is reflected from the focus of the mirror. A ray parallel to the principal axis is reflected from the focus of the mirror. We are imagining a ray from the center of curvature. It will retrace its path. It will retrace its path. Now children, you can see that these two rays are not at all meeting. They are diverging from each other. Okay children, these two rays are diverging from each other. So what we will do? We will extend these rays in the backward direction behind the mirror, and the image forms behind the mirror. Just look at the size of the mirror image, children. The size is magnified, so many times magnified. Yes children, it is a big image compared to the size of the object. And how it is appearing, children? It is erected. This image cannot be caught on the screen, and it is produced because of virtual rays. It is produced because of virtual rays. Therefore, this is a virtual image. Okay children? Now, let us shift the object to focus point. If the object is kept on the focus, the mirror, pole, focus and the center of curvature, the object is placed on the focus. Image at infinity. Let us see how we are getting the image. The pole, focus, center of curvature, image on F, the ray parallel to the principal axis, passes through the focus after reflection. Next, a ray which hits the pole of the mirror will retrace, will be reflected with the same angle. Okay children, will be reflected with the same angle. If you see this children, these two rays are parallel to each other. Do parallel rays meet anywhere? No, parallel lines do not meet anywhere. So even if you extend it backwards, they will not meet anywhere. Okay children, so that is why we say when the object is on F, the image forms at infinity. Children, I hope you understood this. Now we are going to shift the object between F and C. Between F and C. This is F and this is C. Now let us see the image formation with the help of ray diagrams. The principal axis, pole, focus, the center of curvature. Image is placed between F and C. A ray parallel to the principal axis passes through the focus after reflection. A ray passing through the focus. How does it come children? Converse, yes. It passes parallel to the principal axis. Now see where these two things are meeting, where these two reflected rays are meeting. Beyond C. This is where our image will be formed. Okay. So when the object is placed between F and C, the image is formed beyond C. Now how is the image children? Yes, you can see it is a magnified image as compared to the object. It is inverted. Magnified, inverted, and this image can be caught on the screen. Therefore, it is a real image. Now, we will shift the object on C. Okay, children? Object on C. That is according to experiment, it is 40 centimeters. Okay, children? Now, we will see where we are getting the image. The principal axis, pole, focus, center of curvature. Object is placed on the center of curvature. A ray parallel to the principal axis. How does it pass? Yes, it passes through the focus of the mirror. Okay, children? It passes through the focus of the mirror. Now, a ray passing through the focus of the mirror. Once again, we have taken the same rays, children. A ray passing through the focus of the mirror gets reflected parallel to the principal axis. Now, see children, where are these two meeting? Exactly below the object. Yes or no? The two rays are meeting exactly below the object. Okay, children? So, the image is formed on C again. When the object is on C, image is also formed on C. Here, we will be getting the same size of the image. We will be getting the same size of the image as the object. And it is again inverted image and a real image. Now, shifting the object beyond C. Shifting the object beyond C. Mirror, the principal axis, pole, focus and the center of curvature. Object is placed beyond C. A ray parallel to the principal axis passes through the focus, right, passes through the focus. A ray passing through the center of curvature. A ray passing through the center of curvature will retrace its path. It will again be reflected in the same direction. So, where the rays are meeting, the image is formed at that place. Now, compare the image to the object, children. Yes, you see that the image size has diminished. It is still inverted and it is again a real image. Now, if you push the object any farther away, if you move the object farther and farther away from the center of curvature, then you will be getting a highly diminished image. You will be getting a highly diminished image. As we have seen, as the object goes far away, the image gets closer and the size of the image gradually diminishes. That was with the concave mirrors, children. Now, let us have a quick view for rules for drawing ray diagrams for convex mirrors. Yes, children. Now, we know that the focus of and the center of curvature of the convex mirror lie behind the mirror. Okay, children. For a convex mirror, the focus and the center of curvature lie behind the mirror. Now, as the ray, as the ray, incident ray parallel to the principal axis is hitting the mirror, then it is getting reflected. It is getting reflected such that it appears to be coming from the focus of the convex mirror. Where is the focus, children? It is behind the mirror. Yes, it is behind the mirror. Okay. So, the incident ray, if it is parallel to the principal axis, after reflection, it gets reflected in such a direction that it appears to be coming from the focus of the mirror. Okay, children? If the incident ray to a convex mirror is parallel to the principal axis, then it reflects in such a direction that it appears to be coming from the focus of the mirror. Similarly, let us look at the second rule. The second rule will be the converse of the first rule. If the direction of the incident ray, now you can see here, this is the incident ray, children, coming obliquely. If the direction of the incident ray is such that it appears to be going towards the focus, if it is appearing to be going towards the focus, then it passes parallel to the principal axis after reflection. Okay, children? It passes parallel to the principal axis after reflection. So, it is the converse of the first rule. If the incident ray to the convex mirror is such that it appears to be going towards the focus of the mirror, then it reflects parallel to the principal axis. The next rule, rule number 3, if the incident ray to the convex mirror is such that it appears to be going towards the center of curvature, then it reflects in the same direction. The same rule like the concave mirror, children. The only thing is that we have to use the word appears to. The incident ray, if the direction of the incident ray is such that it appears to be going towards the center of curvature, then it retraces its path. It retraces its path, or the reflected ray goes back in the same way as the incident ray. If the incident ray to the convex mirror is such that it appears to be going towards the center of curvature, then it reflects in the same direction. This is rule number 3, children. So, by the help of these 3 rules, we can draw ray diagram for convex mirror. Unlike the concave mirror, convex mirror has only one option, because wherever we keep the object, it always gives a virtual and diminished image. The convex mirror, principal axis, pole, focus, you can see, children, it is behind the mirror, and the center of curvature. The object is placed at any position. A ray parallel to the principal axis, a ray parallel to the principal axis is reflected such that it appears to be coming through the focus. It appears to be coming through the focus. Next, a ray which appears to be going towards the center of curvature. A ray which appears to be going towards the center of curvature retraces its path. It retraces its path. Now, virtually these 2 rays are meeting behind the mirror. Yes, children, the rays that we have extended backwards are meeting behind the mirror at this position. So, image will be formed at this position. Just look at the image, children. The image is highly diminished as compared to the object. Okay, children, the image is highly diminished as compared to the object. It is erected. Yes, children, it is upright. It is not inverted like concave mirror image. It is upright, erected, and it is a virtual image. The images that are formed behind the mirror are virtual images. Okay, children. So, this is the ray diagram for convex mirror. Irrespective of the position of the object, the image distance does not change much for a convex mirror. It always falls between the pole and the focus of the convex mirror. So, children, I hope you all have understood the ray diagrams clearly, as they are very, very important. Please practice them thoroughly from your textbook. And now let us see what we have learned today. The concave mirror forms different types of images for different object positions. As the object moves away from the mirror, the image gets closer to the mirror and image size gradually diminishes. Children, this we have seen in the observation table. Yes? Then we have seen the 4 rules for drawing ray diagrams for concave mirrors and 3 rules for drawing ray diagrams for the convex mirror. Then we have seen the ray diagrams. We have seen 6 ray diagrams for concave mirror and 1 ray diagram for the convex mirror. So, children, here are a few questions to improve your learning. Please take help of your textbook to answer these questions. Children, these questions are framed based upon your exams also, so that it will help for your preparation also. What are the material required to perform the activity for observing different types of images formed due to a concave mirror? So, you have to write what are the materials we have taken for the lab activity that we performed today or demonstrated. Explain the procedure to perform the activity to observe different types of images. Okay, children, here is a small question, children, for you to think. It is not a problem, though I have given the numbers. If the object is placed at a distance of 30 centimeters from a concave mirror of focal length 20 centimeters, then discuss about the image formed. You have to discuss about the image formed there. Okay, object distance is given as 30 centimeters and the focal length is given as 20 centimeters. You have to discuss the image formed. Can a concave mirror form an enlarged and erected image? Discuss. Yes, children, do you remember concave mirror forming an enlarged and erected image? Discuss this. Write in what situation you have seen this. Draw the ray diagram for an object placed in front of a convex mirror. Let us see you all in the next session. Thank you.